There. In this particular video, I will be going through the concept of the product rule. The product rule is a differentiation technique that is useful when two functions are multiplied together. They don't necessarily have to be just polynomials like in the examples, in this particular example here, because in Unit 3-4 methods, you will be going through different types of functions being multiplied together. Let's say, for example, an exponential multiplied with a trigonometric ratio, such as sine, cos, or tan. But for intents and purposes, we'll be using polynomials because we currently only have the product rule and the power rule at our disposal. So from the VCAR formula sheet, we can see that this is the particular formula that's given to us. It shows us that we are differentiating u times a v. So in between the u and v, there's a multiplication sign. That would equal to u times the derivative of v plus v times the derivative of u. And in between, there is a plus. So that's a main characteristic. An alternative way is that if I write down, instead of u and v, I write down two functions, f of x and g of x. Then you can see that it's f of x times the derivative of g. And you add that with, so it's similar up there. You add that with g of x times the derivative of f of x. So the interpretation you can see here, it says derivative of two functions, first function times the derivative of the second function, plus the second function times the derivative of the first function. So all three of these is just explaining the exact same thing. Okay, so let's put that into practice here through this illustrative example, and then I'll go through two examples here below. The illustrative example says, consider the function y equals 2x squared plus 1 in a bracket times 5x cubed plus 16 in a separate bracket, and find dy dx using the product rule. So you can see here in the first line, we've stated what the product rule is, and I've color coded each of these so it aligns with u and it aligns with v. And you can see how u and v is used there in purple and green. And I've used du dx and dv dx respectively in different colors as well. So there's a grid that I can set up. It's almost like a 2x2 grid where you display u and du dx, and you also display v and dv dx. So I should probably change this here. It should be v dv dx. And you can see how it all meshes together. You can apply that there. So we've got each component 2x squared plus 1 times dv dx. Oopsies, it should be dv dx here, which is 15x squared. You can see it's plugged in. And we've got v times du dx, which are those two components there. So the product rule, substitute the necessary items or necessary terms, and you expand, and then you simplify, and there you go. Yes, alternatively, you could expand in and then just differentiate using the power rule. But the purpose of the product rule is to understand how to apply it, because let's say, for example, if you have e to the power of x times sine of 2x, you would not possibly, there is no way for us to expand that in order to differentiate it. So we need to use the product rule for an example like that. So let's go through the product rule here. We can already identify that there is u and v. So we've got u, we've got v here. And it's good to identify each of these components here so that you can apply the product rule. I've allocated 2 marks to this particular question, because I want to scaffold and I want to make sure that you write down all the necessary bits and pieces before we get going. Okay, so initially I want you to write the information down so that you can clearly see how each item is displayed. So you can see the u dx here. If we differentiate the u, it will turn into 3. And if we differentiate the v there, which is the v dx, that will turn into 2x plus 4. Now keep in mind that each of these items here, or each of these expressions, or all have brackets around them. Okay, so if we do multiply, then we need to place some brackets around them, including this top one here as well. Okay, so let's go ahead. We've got our grid there. I might go across here and say, and differentiate now. So looking at our front expression there, we do have a y, so we will use Leibniz notation and express it as dy dx. So I'll write down the formula first. Here's the formula: u times dv dx plus v times du dx. In the next line here, we're going to substitute. And we might run out of space here, but that's okay. We can just always jump a line. U times dv dx, so we've got 3x plus 1. 3x minus 1 here. Multiplied with dv dx, which is 2x plus 4. Plus v, which is x squared plus 4x plus 3, times du dx, which is 3. And when I'm writing this out, I am looking at these components here on the left side of the page here. What I might do is I might just shrink this a little bit and place it over here, and just place a bit more emphasis on this section here. The next step was for us to expand and then simplify. So let's expand. We've got 6x squared plus 12x minus 2x minus 4. And we're going to expand this 3 inside and distribute it inside the bracket. We've got 3x squared plus 12x plus 9. Okay. So yes, you can write dy dx again and again, but you can see that they are already in line with each other. So dy dx here should equal to, we are running a bit tight on space. I might move this up here. I might relocate a few things. One moment, please. So we have, we just need to simplify now. So we've got 9x squared, group the like terms. We've got 24 minus 2, that's 22x. And we have plus 5 for the constants. Okay, that's all. That's it for that particular example there. Now, in terms of identifying u and v, now it's easy for us to identify that this is the product rule because in between you can see that there's a times. Okay, so that's what you're looking out for in each of these questions. You're looking out for you ask yourself, what's in between the functions? So what's in between each bracket? Oh, there's a times. So times meaning that we need to use the product rule. Okay, product being associated with multiplication. Now we can also see here that u and v are here, but let's try a different strategy or different approach. We know that's u, so we know what du dx here. We'll write 2. And we can also see what dv dx here is as well. That's 2x. So when we write it like that, you can clearly see that each of those components are already there, so you don't have to rewrite it again. There's your u, there's your dv dx, there's your v, there's your du dx there. So let's go ahead and we'll write out dy dx is equal to u times dv dx plus v times du dx. Now, since we are doing year 11, I want you to write out the product rule every time so that you can get used to seeing it. If I write it down, then make sure you write it down as well. Let's make the substitution. We've got 2x plus 3, which is our u, times our dv dx, which is 2x, plus our v, which is x squared plus 5, times our du dx, which is 2. Okay, so just looking at this grid here. So let's expand and simplify. We've got 2x, I'll just draw some lines here. We've got 2x, and then we've got this one here, and it seems like we're distributing backwards, but that's absolutely okay because we know the rules of the game. So we've got 4x squared plus 6x plus 2x squared plus 10. And last but not least, making sure that we simplify. And although I understand that that is in an expanded form, we can leave it as such unless if we need to do anything further to it. We could factorize out a 2. If you want to factorize out a 2 as the highest common factor, be my guest. That's absolutely fine. So there it is. That's the product rule. Make sure you get your practice for this exercise here, and hope you find success with it.